So for today, this is day 2 of arithmetic and geometric series. A series is one where you add them all up. And this, I'm going to tell you the formula right here for the geometric series equation, but I wanted to start with an arithmetic one. So I gave the kids this, and they're working on it right now to figure out the first 6 terms of that arithmetic series. And then I hope that they're going to remember that formula that helps them add up those 6 terms without having to just simply type them all in the calculator. All right. All right, so by now, I'm sure you guys have stuck in n equals 1, and then you got 2 times 1, which is 2 plus 3 is 5. When you stick in n equals 2, then you got 2 times 2 is 4, plus 3 is 7, 5, 7. Are you starting to catch on that it looks like you're just going to add 2 each time? And if you want to do a third one, maybe just to be safe, n equals 3, you stick in a 3. 2 times 2 is 6, plus 3 is 9. And you're like, yep, it's definitely adding 2 each time. 5, 7, 9, 11, and then 13. And then how many do I need? 15. I need 6 of them because I went from 1 to 6. And now I know you can add them the old-fashioned way. 5 plus 7 is 12. Then add 9, then 11. Then it's, but do you get this? Could be a list of 100 things that you have to add. So what was that formula again? Can anybody recite it that would add up a series of numbers like this? Hint, little Friedrich Gauss sat in the back corner and he did a little pattern. Remember how that worked? What were some elements of what he did? Do you remember? Say it if you know it. He did the ends, yeah. So like in this case, we'd do 15 and 5, and that makes what? 20. And then could I keep adding? Yeah, look at that. It's just, look at that awesome pattern, 20, 20, 20. So 20, 40, 60. But again, we're using the fact that there's only 6 terms to our advantage in saying 20 plus 20 plus 20. What would we really want to do? We would want to add the first and the last, and that makes 20. And then we times that by what again? How many there are, which is what in this case? How many terms are there? 6. And then I divide by 2. Okay, so it's how many you have divided by 2. And then you times by the first plus the last. All right, so let's see if that's stuck. 1 plus 5. Actually, let's start with 5. It'll make my life a lot easier. 5 plus 5 is 10, plus 5, etc. Okay, so this is an adding one again. And let's do, the first 200 terms of that. You might be thinking to yourself, well, do you have to tell us the 200th term? No, you can figure it out if you know the right formulas. What is that formula? Not the one that adds them all up. What's that other formula? A sub n equals, I hope you remember it. They'll use that to figure out what the last term is. You'll need the first term, the last term. You'll need to know how many there are. You got everything you need to know. I'm going to pause for a minute while you try to add up the first 200 terms of this series. I'll pause for a second. All right, I'm sensing a fair number of groups are stumped on that formula. So, what was that formula again? Somebody's got it. Starts with A plus. Yes. A plus D times n minus 1. Yep. And D is the common difference. All right, you can see how powerful these formulas are, and if you're stuck without one, it could be really bad. So make sure you got these formulas down. That's the formula that'll help you figure out what the 200th term is. Then I want you to actually add them using that other formula. I just don't even like to say it's a formula. I just like to say it's the Friedrich method, where you add the first and the last, you times by half of how many you have. All right. Pause again while you finish this puppy off. So let's see if you were hanging with this thing correctly. The 200th term, you'd stick in, you want A sub 200, right? So n is 200. So you put a 200 here. You got to know D. D is your common difference, and it's going up by 5 each time, so I put a 5 there. A is the amount you started with, which was also a 5. Then A sub 200, the term we want, is 5 plus 5 times 199. Can you save me some time? What does that come out to? 1,000? So then, the last term in this list is 1,000. Why do we really care so much? Because we need that to do the Friedrich method of the first and the last get added together, and then we do that how many times? Half of how many we had. So 1,005, which is this one plus this one, times how many did we have? We had 200 terms. And so we say 200 divided by 2. Why? Because we're doing sets of 2, right? So this half of the group is how many groups we'd have, or half of the total. So then 100 times that adds another 0, 10050. Raise your hand if you had that one right. Awesome. Now, what's new? Oh, question or comment? Yes? Okay, I multiplied by 100. Oh, you're right. I think it does have another 0. I'm double checking here. This is going to be a 100. Yes, timesing by 100 does add 2 zeros. I'm sure some of you guys just kind of didn't notice there was an extra 0 missing there. But yes, thank you for making that accurate. Okay, so then how do we do this when it's geometric? And what would the difference be? Well, geometrics get a lot bigger. Think about that. Like, let's just take 2 a few times. This is the doubling thing. 2 turns into 4, turns into 8, turns into 16, 32, 64, 128, and within only 1, 2, 3, 4, 5, 6 doubles, we're at 128. Okay? Now, what does this apply to? It's kind of interesting. If you get 10% return on your investments, a lot of people figure they can get 10% in the stock market or investing in Bitcoin or whatever. And I'm not saying Bitcoin's a great idea right now. It's already up 17,000%. But anyway, if you had invested just a little bit, like I should have, and I really wanted to, and just didn't take the time to follow through and actually buy it back when I had it at $200, and I was like, I'll just put a little bit in here. That's what you do. You buy a little bit of this, a little bit of that, buy a little bit of, insurance company, Geico, for example. You can buy that online. You could buy a little bit of Geico. Means you own a little tiny bit of that company. And if it turns out that company does really well over time, the stock will grow. So anyway, if you know the rule of 72, parents a lot of times know this one that were trained up back in the day. It's take 72 and divide by whatever percent return you get, and dividing by 10 is really nice. So let's say we use 10% return. And moves the decimal back, and yes, every 7.2 years your money will double. So this is like 7 years, another 7 years, 7 times 3, 4, 5, 6, 7 times 6 is 42. And then it was 7.2 years, so let's say it's about 43 years later. You had 2,000, now you have 128,000. That's a lot. That's a lot of growth. See what I mean? So if your money doubles every 7.2 years, this is an example of what could happen. All right, so then what Mr. Guy who had figured out lightning makes electricity, Mr. Ben Franklin, there we go. Mr. Ben Franklin wanted to teach the lesson of how that things grow like that exponentially. And so he said, I don't want you to touch the money that I give you. Did I tell you this story? I think I did. For 100 years. And so let's do that one, okay? And we'll make the assumption that the money didn't grow as fast as that because there wasn't as good of things to invest in back then. When he first started that, there was no stock market. Like, it was harder to figure out what to do with the money to make it grow. I mean, there was good things you could do. Back then, real estate was really cheap. And, could have bought some real estate with some of your money, etc. But let's go with that 10% growth idea, except if it goes the other way, if you take 72 and divide it by 7.2%, then it'll take 10 years to double. All right, so I'm going to say that your money doubles every 10 years. And let's say that you start with $5,000. And we're going to make it double every 10 years. Okay? So you get I'm starting a sequence, or actually, since I'm going to add it all up at the end, a series. All right. Now, just to clarify, this would actually not give me the right answer, because a series is going to take how much you had at the end of each of these years and then add it all up. Really, how much you have is just the last number in this series. So this is slightly different. All right, so I'm going to take my 5,000 and I'm going to say that it doubles every 10 years. And then the question becomes, how much do you have, or how much, if you added up your series, you'd have at the 10th year. So every 10 years, you'd double it, you'd have 10,000 the next time. And then ... But let's do that over the course of 100 years. So in other words, 10 doubles. Now, I don't want you to just actually do this by hand, because it really isn't going to prove much. What I can ask you to do at this point is, you should know a formula that should be able to tell you the 10th term in this sequence. That much you should be able to do with a formula. So find me the 10th term with the formula. Hint, the formula starts with a sub n again, but it's got an r in it this time. Do you remember that formula? Try to drag that back into your head. The act of trying to remember it helps it stick when I do tell you what it is. I'm going to pause for a second while you try to remember that formula. How many do you think you have that formula, just out of curiosity? That's about half the class. I'll pause for a second. Okay, in case it's not coming to you, it goes like this. You take your amount that you had, and you times, because this is a geometric, so there should be multiply involved, right? By the r to the power of n minus 1. How many had that down already? You knew that. All right, good. If you didn't have that one memorized, memorize it. Now, I don't know what the last term is. It's a sub 10 is a, my starting, which was 5,000, times r. Well, what is this r, the common ratio? Take 10,000 divided by 5,000, and you get 2. To the power of n minus 1. In this case, that's 10 minus 1, so it's 9. So 2 to the 9th times 5,000. So at the end, the last term, which is how much you would have. Can you tell me what they came out to? It's a really big number. I don't know what it is. Got it? The calculator? 2,560,000. That's starting with only $5,000. You think some of you might be able to scrape together $5,000? I don't mean right now. Some of you actually probably have that much, because I know some kids that just save every gift they ever got from grandma and grandpa and work as a babysitter and etc. And all of a sudden they've got $5,000 already. Well, mostly though, people are saving that for college. You don't have to spend it. But what if you didn't have to? If you take that 5,000 and you buy something that gets you 7.2% growth, 100 years from now, I know you'll probably be dead. Although there's a chance some of you are still going to be living 100 years from now. The advances in medical technology are pretty dramatic right now. That's not the normal life expectancy for you, but life expectancies change over time. What if, like 5 years from now, they do find out that, hey, we can prevent cancer. All you got to do is take this pill every day that's got antioxidants in it that are super rare, whatever, powerful. Or maybe it has to do with gut bacteria. And they figure out that everybody's gut bacteria has been following them up. They could get super bacteria that's going to fix that, and you won't get cancer anymore. Or they fix Alzheimer's because they figure out that it's actually a concentration of, I don't know, some kind of bad stuff in your brain, and then you stop, you take something that counteracts that, and all of a sudden there's no Alzheimer's anymore. I mean, these things are possible. It wasn't that long ago, and you know, tons of people died from stuff that we can fix now. You know what I mean? So a few years from now, you might be able to keep from dying, and you might be 120, and maybe even still able to have fun and, you know, enjoy life. All right, so that's an example problem. Here's a much simpler one. But we need a formula to find out how to add up all those terms in between. All right, so what was the formula for the arithmetic one again? A sub the formula that adds up all of those. Well, that was actually the one that I just keep telling you is Friedrich's formula. Okay, and that's the one where you take n is how many things you had, and then what do you do? And then you times by what again? Well, technically it's n divided by 2, and n was how many terms you had. And then it's a plus, what's the last term in the sequence? A plus d times n minus 1. Here's your first one, here's your last one, here's them added together, and times by n over 2. So there's the formula that gives you the growth, or the total in an arithmetic series. For a geometric series, I'm going to go back to that slide we started on and reveal it for you. Unfortunately, that won't make it reveal on your iPad, so you're going to have to copy it down. But here is your big hoo-ha formula. S sub n, I'll move it up, sorry. That's a series of n numbers, like let's say it was 3. So let's say our series was 3 numbers. 20 times 2 is 40, times 2 is 80. Oversimplifying, but do you get this would add up to 140? If it was just a set of 3 numbers, started with this, growing by times 2 each time, would you try to use this formula and see if you can get it to equal 140? Because that's what it should equal, if you know how to use this little formula right. Stick the numbers in the right places to make this series get added up with this formula and make it equal 100 and, what does it actually add up to? Get 140. I'll pause for a second while you verify that thing works. So did you stick in, n was 3 because I have 3 terms. So then n is 3 everywhere. R is the common ratio, the rate at which it's going up is a 2. So this is 2 to the third, and this is a 2. And then a is the amount we start with, which is 20. So then this is 1 minus 2 to the third is 8. 1 minus 8 is negative 7. 20 times negative 7 doesn't seem like it's off on the right foot here. But then when we divide by 1 minus 2 makes negative 1, it gets us back to, oh, I guess that'll fix the negative problem. 7 times 20, 140. Cool, worked. All right. Would you, obviously you wouldn't need the formula if they were all that simple, but what if we had a problem like this? John, and this is a actual typical ACT question, which would be handy to know this formula to do. John is calling people to sell life insurance to them, and so he is calling more people every day. In fact, he sets out a goal to double how many people he calls each day for 7 days. Okay, the question would be, how many people did he call over those 7 days? And I didn't tell you enough information quite yet. He doubles how many people he calls each day. He works for 7 days at this. How many total people got called? What do you need to know that I haven't told you yet? How many he started with? Let's say that he started by calling just 3 people his first day. 3 people the first day. And he doubles how many he calls each day. How many total did he call in the week? I will pause for a moment while you give that one a try. Use this formula I just showed you. Okay, so anybody who knows the principle of doubling would know that this problem is probably a little unrealistic, because at the end he's got to call so many people each day, there's just like no way the dude could do that. If you just write out all of them, I kept it short enough with 7 days that it's something you could probably just add all up. But how I wanted you to use this formula, I hope you stuck in n was 3. N is the number of days, so, sorry, 7. And the amount it's starting with is 3. And the r, which is the rate it goes up by, is it's doubling each time. So then this is a 2 and a 2. And 2 works pretty well because then the denominator just comes out to 1, or in this case, -1. All right. And this is 2 to the n was 7. So to simplify it down, I have 3 times 1 minus 2 to the 7th, whatever that is, all over -1. Now 2 to the 7th, I know up to 2 to the 5th is 32, so let's see if I can do it from there. 2 to the 6th would be 64. 2 to the 7th is 128, is that right? Somebody verify that? Okay, good. 1 minus 128. And 1 minus 128 would be -127. The negatives are going to cancel. So it's 3 times 127. So let's see if I can do that the rest of the way in my head. 360, sometimes 21. 381, is that right? That's the 2. Yep. Did you get 381? Raise your hand if you got 381. Okay. Now remember, 381 isn't how many people got called on the last day. That would have been a different formula. I'd like you to use that different formula and figure out how many people got called on the last day. What we just figured out was how many people total got called. Use a different formula and tell me how many got called there on day 7. There's a different formula that does that. I'll pause while you give that a try. Okay, that formula is A sub n is equal to A times what? R to the n minus 1. And what is the n? N was 7 in this case. So we go 7 minus 1, and we started with 3. So you should have said amount sub 7, the 7th amount, would be 3 times r, in this case, is 2. To the 7 minus 1 is 6. And 2 to the 6th is, what is that, 64? Okay, so 64 times 3. 180 plus 12. 192. Raise your hand if you had 192. Okay, cool. All right. You know everything that you need to know if all we were going to do was add up a series of either geometric or arithmetic terms. Now, how could they tweak it on you and make it more complicated? All right, so I start with 6. And my next term is 4x minus 17. In other words, it's got a variable in it. Could they do that? Sure they could. If so, would you tell me what the 12th term is? I'm going to pause for a second. Try to figure out the 12th term in that. And now, did I tell you if it's arithmetic or geometric? So then you get totally different answers based on that, right? I won't make you do both. Which would you rather do? Arithmetic. Let's try the arithmetic one. Tell me if it's arithmetic. If it's arithmetic, what would be the 12th term in this sequence? I'll pause for a second to give that a try. Okay. The hardest part is to find the D, the common difference. Always take this one and subtract that one. 4x minus 17 minus 6. Okay, so that means it's 4x, and then the two negatives go together, minus 23. That is D. Now I can just stick it into my little formula. I know that formula. To find the 12th term, I go A sub 12 is A plus D to the n minus 1, or not to the, times the. And then A was the starting amount, which was 6, plus that common difference, 4x minus 23, times n minus 1. What was n? N was 12, so 12 minus 1 is 11. There you go. Why does your answer have to have an x in it? Because it depends. Depends on what x is. Any questions on that one? Okay, do you remember at the beginning of this, not the beginning, at the very beginning, but we had some that were like this. 6x plus 4 turns into 21x minus 11, and we said it's geometric, and then find the next term. Just the next term. I'll pause for a second while you give that one a try. This is geometric. What's the next term? Okay, we need our r this time. You should have taken that divided by that. 21x minus 11 over 6x plus 4. And if you can factor it, you should. This one doesn't happen to have anything cancel, so then that's it. That's your r. And then if you're going to find the next term, you just take this times this. That's all there is to it. So I could say 21x minus 11 is on the top, and I times it by the other thing on the top, so I could say squared all over 6x plus 4. See what just happened there? That's just me taking the r, timesing it by this term, putting it over 1 so I can see that that's on the top, and then there we go. Okay, and the last kind, now, why does it matter that I got 3 terms? Because if this is truly arithmetic, now you could tell me what x is. Arithmetic, find x. And I don't mean like it's 6x plus 7. No, you'll be able to tell me x has to equal this fraction. If this is arithmetic, find x. Hint, you really just need one big equation. But you can't just go this minus this. That's not an equation. I'll pause for a second while you figure that out. Okay, here's the key to this one. When you do subtract this minus this, that just gives you something with an x in it, and you have to set it equal to something. So then you say that must be the same as this one minus this one. Okay, so I'd say 9x minus 11 minus, parentheses, so I remember to distribute it, 5x plus 12 would have to equal 14x plus 17 minus 9x minus 11. So it's a fairly big equation, but it's only got one x in it, so it's just a matter of grinding it out now. And I'm sure the answer came out to some fraction or decimal. I'm going to use Dice of Destiny to see what you guys got. Row 6, fifth person, 1, 2, 3, 4, 5. That's going to be you, LP. What did you guys get when you solved that down? Okay, did you know what equation to make? Or did you not have that equation? Okay, all right. So I will call in somebody else. And this is row 6, person 2. That's going to be you in this case. Yes, you, Mr. W. A little louder. Negative what? Negative 51. Did anybody else get negative 51? Ooh, a bunch of people did. That's probably it. Okay. It's just a matter of solving an equation. It just happens to have, don't forget to distribute the negative. If you forgot that that's a negative 12, that's a really common mistake. Okay. All right. Any questions so far? Ben, your homework is the first 3 pages of day 2's homework. We are not going to do day 3. I also aren't holding you responsible for it as far as testing. So I'm going to go look at day 2 with you. Find the homework that says day 2. See, it starts by saying day 2 on top. In my smartboard, now I might have added pages and stuff. Mine says it's page 51. So I don't know if that's close to where is yours. Yours is what? 45? Okay, thank you. So find this on page 45-ish. And we're going to do this one, the second page, and the third page. That's it. So let's do the first couple together. All right. They saved 50 in the first week. I think I'd always start by making a little list of my first few terms that they give me. 55, 60. Ooh, I caught the pattern. Looks like this is arithmetic. And they want to go for 10 weeks. And then they say, how much will they save in 10 weeks? All right. Now, just to clarify, they saved this much in the first week and they throw it in the bank somewhere. And they made this much extra in the next week, and now they throw that. So in other words, they're asking you to add up the first 10 numbers in this series. Is that anything new? No, you already had the arithmetic sum equation. That's the one that Friedrich does. That's the one where you just add up a set of numbers. So really it'd be nice to know what they got in the 10th week, right? So we got the first 3 weeks, dot, 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 dot. You better figure out what the 10th week is so that you can add the first and the last, and then multiply by half of how many terms you had. That ring a bell? All right, so let's figure out the 10th week. So in the 10th week, that's this formula. A sub n equals A plus D times n minus 1. If you haven't written these down somewhere, you're really going to struggle. You got to have the formulas written somewhere. Okay. And that's the one that tells us the whatever term, the 10th term in this case. So we put a sub 10, n must be 10. Our common difference, if you can't figure that out by now, you're really lost. Common difference and the amount come from this. All right. Now, there's going to be twists because it's the real world, and so they're going to ask you to, like, it's a little bit more complicated than what we were doing in class. Because, for instance, it says, after you've got this, how long will they have to continue savings if their target is to save $5,000? Well, obviously, they aren't at $5,000 by the time you're done, or that would be a dumb question. So how do you keep going until? Do you have Friedrich's general formula yet? If you don't have it, here's how it would go. The sum for an arithmetic, the sum is you take n over 2 and you times by the first term, which is a, plus the last term, which is a, plus d times n minus 1. So many little formulas. This is the formula that Friedrich used to add the first and the last, and then times it by half of how many there are. So what do we want that to equal? We want that to be 5,000. So you make this 5,000, and you solve. You know some other stuff. You know A, the amount you started with. And you could solve for n. All right, so if, again, I've said it enough times that it's probably getting sickening, but you got to know these formulas. Got to have them down. Got to have them memorized. All right, so on number 10, just do one thing at a time. You got 2 parts. All right, I'm feeling like this is a little long. I'm changing my mind to say you may skip number 12. The very last one that was assigned today, you can skip that one. I do want you to do this algae one, because that looks very like what we test you on, that kind of stuff. Okay, that's all I got for you for today.